Alright, welcome to today's lesson on files, where we're going to be learning how to import data from a file as well as to output data to a file that's stored on our computer. To do this, we have to make use of two packages. The first is the java.io package, and this package contains the classes that are going to allow us to actually connect to a file on the computer. The second package we want to import is the java.util package, because this contains the data for the scanner classes so that we can actually stream data from the file like we were before streaming from the keyboard. Now, whenever we want to input from files or output to files, we have to follow a three-step process. The first step we have to do is to actually access and open the file itself. Once we've done that, we can then either input data or output data to the file. And then finally, we want to close the file to free up any memory that's being used in that actual file while we're running with it. So we'll start by learning how to open a file. We open a file by first creating a file object, as seen in this first line of code here. It requires us to provide a file name of that file and the entire path of where that file is found as a parameter. Once we've created that file, we can then use it as a parameter in the scanner constructor, so that instead of using system.in to get data from the keyboard, if we provide it the file, we can get the data from the file itself. However, this assumes that the file has been entered in correctly. If I have some sort of a typo, or I have indicated a file that isn't there, my program is going to crash. So how can I prevent that? Well, we can do that by checking for the FileNotFoundException. This exception is thrown whenever I try and instantiate or create a scanner with a file that doesn't exist. To look for it, we have to go back to using a try-catch statement. This is going to allow me to try to instantiate a scanner object using that file. And if the file is not found, we're going to throw that exception, and we can have the catch clause run some statements that are going to allow us to give some more information to the user instead of just crashing the program. So that's going to look something like this. We have this file example program that I've written. So I've created my scanner here, which has nothing in it. And then what I'm going to do is I'm going to run my try portion of the statement. In the try, I'm going to create my file, which I've called file.txt, myfile.txt, and then I'm going to use that file object as the argument for my scanner constructor. If this throws the FileNotFoundException, it's going to run the catch statements that are found inside this clause here. And there are three statements we need to look at. The first one is this one here. What this particular one does is it outputs an exception statement saying that my file, so the one that I had here, that the system cannot find that particular file. That's the message that's associated with this particular exception. Then it's going to print the line saying in and the current directory where I am. So whatever directory that my Java file is being run out of, it's going to say, well, I can't find this file in there. And then I'm going to try and exit my system. Now, by putting a 1 here, I'm stating that the program has ended as a result of an error, as opposed to a normal end, which would have a 0 in here instead of a 1. Okay, so if we were to compile this and run it, you can see here that I do have a file that says this is my file. So if I run it, you can see I'm outputting this is my file. But if I look for something that doesn't exist, some sort of gibberish file, and we run it, you can see that the message shows up there. Now, because of the way Dr. Java shows, it's going to reset the interactions, but you briefly saw that in green, the message that we were outputting as part of our catch clause to give more information as to why our programs crashed. But we still have the problem where our programs crashed, so we have to look for an alternative. What we can do is we can put that whole trying to open a file and scanner into a loop that is going to run until we find a file, so it gives it more opportunities to input the file. And when we do that, we can also add a couple of methods in here that we can use to give more information to the user so they can understand why the file is not working. So we can check to see if the file is a directory, we can check to see if that file exists, or if that file is readable. These are all methods that exist in the file class. So if we try and implement that, that looks something like this in our second program here. So we've got a few extra things in here because I'm going to be using user input in order to actually access the file. So I'm going to ask them to give me the name of the file, which we do here, store that into a string. I set up an infinite loop, so this is going to go forever until you actually end up giving me a file. I could set this up so that it allows you to write the word exit in here so it doesn't actually go forever, and set up an infinite loop if you decide you change your mind. But what I'm going to try and do is I'm going to get my file, so I actually create my file itself with the name that you've given me. Then I'm going to try and use that as my scanner object. If it works, I'm going to break out of this loop and move on with my program where I can output whatever I want to output. However, if it doesn't work, I'm going to be catching this particular error that we threw. And that error then is going to go into these catch statements. So you can see I've used one of those file methods where I can see if that file doesn't exist, output, while error, that file doesn't exist. Otherwise, I'm going to go back with the default sort of saying, well, we can't find that file. So you can see what that one looks like. So if we run this, you can see I've got an opportunity to write my file name. So if I type in some sort of gibberish in here, we got error, that file does not exist. So I can try doing my file.txt and it does it just fine. So now we need to figure out how, now that we've connected to our file, how are we going to actually input data from the file? Well, it does that line by line, just like we did when we were inputting from the keyboard. This uses the following scanner methods that we worked with before. So we've got has next line, which tells us whether or not there is another line in the file we've worked with. We've got the next line method, which is going to take all the remaining text in a current line of the file and then send it all back. Next just gets the next token, and tokens being separated by any kind of white space. So space on the keyboard, a tab button, and enter, all those would be examples of white space. And then we've got the specific types we want to input, so next int, next double, and so on. And again, if we get the wrong type, we're going to get a type, an input mismatch exception that we can check for as well, like we were doing before. So let's say I wanted to import data from a file that had a whole bunch of names and contact information for a person. And what I did is I put the name separated by a space, and then the age with a space, and then their phone number. If I had a whole list of these, I could set this up in a loop. So as long as I have another line or another information, I can get the first name, the age, the phone number, get rid of the rest of the line, go back up, get the next name, the age, the phone number, and so on. I could keep doing this, doing stuff with this information as I go. The problem with this particular setup is that I may have someone who enters sometimes just first names and sometimes both first and last names. And by having these spaces in here, it's going to throw me off because I've got the next, which is getting a string. Then when I try and get the next thing, instead of getting an integer for the age, I'm going to have that last age pop up, and that's going to give me an error. So to fix that, we can use something called a delimiter. A delimiter is the character or set of characters that separate one token from the next when we're getting data from a scanner object. Now, as I said before, the default delimiter is a white space character, so a thing like a space or a tab. But if I want to use something different, I can separate with a different delimiter, like a colon. If I set up my file separated by colons, I can then have whatever spacing I want. I could have a person with 3 names, 8 names, 12 names, whatever I like. Right? I could have spacing inside the phone number if I like, because it's not checking for spaces when it gets the next whole string, it's just looking for the colon. So to get that whole next thing, then the next int, and then the next string again. If we want to set the delimiter, we do this particular line of code here. So whatever my scanner object is, so that scanner object dot use delimiter, and then provide the string that I want to use to separate the individual pieces of data in my file. I just have to make sure that I've saved my file with that same format in order for this to work. Now to output is very simple. It's done exactly the same way we did input. The only difference is instead of creating a scanner object to get the input, we have to make a print writer object that is going to use that file as its parameter. So it looks exactly the same, except instead of having scanner here, I've got print writer. Instead of having scanner here, I've got print writer there. And then I use the print writer methods, which we've already worked with before, print and println. And then finally, as we said before, we need to make sure we close the file. We just put whatever the file is .close, and that will close the file for 2 reasons. Number one, we want to free up any resources in memory that's being used to have that file open. And as well, when we're outputting the file, if you don't close it, it won't close that file properly and save it properly, so that when you try and open it later, none of the data will actually be there. So if you want to keep that data, you got to make sure you close it before you exit out of your program. That's it. That's all we got time for today. So we'll see you in class tomorrow, where we can practice what we've learned.